Alright. In this program, we're going to learn about how to convert a program written using iteration to check whether a number is composite or not into a recursive form. Alright. So before we begin, we must understand what a composite number is. So a number is said to be a composite number if it has one or more factors other than one and itself. Now, this fact should be obvious to you right now that the factors of num excluding one and itself would lie between 2 to num by 2. Now, this can be demonstrated by finding out the factors for 6. You see, the factor for 6 would be 1, 2, 3, and 6. Now, if you exclude 1 and 6, that's 1 and itself, we are left with 2 and 3. Therefore, the range of numbers between which a factor of 6 would lie is 2 and num by 2, that's 3. And this is true for every other positive number. All right. So let us see what the iterative program is. So the iterative program has been written over here, and here we are calculating the number of factors that the number has, excluding one and itself. And then if the number of factors is greater than 0, it means that the number is a composite number. Otherwise, it is not a composite number. So let us try to write a program, a recursive program for this iterative program. All right. Okay. The first thing is to create a class. And let me just maximize this. All right. And then we will import the scanner class. Right. Class composite number. Okay. Now, it's our task to come up with a recursive solution to this particular program. So, as you from the previous video, you already know that the return type would be same as the return type of the boolean of the iterative function, right? Followed by the name of the function. So let's name this rec composite, right? Rec composite version 1. Okay, and then we need to identify the variables which have been declared outside the loop or before the loop, and as well as the loop variable. So if you check out the loop variable, just change the color of the pen. So num is a variable that has been declared outside the loop. Fact count is a variable that has been declared outside the loop, and I is our loop variable. And these variables will form the parameter list of the recursive functions. So int num, int fact count, int I. All right. Now, next we must identify our base condition. So our base condition is found out by inverting our test condition. So this is our test condition, isn't it? Therefore, the inverted condition for this, or let me write it below, for this would be I greater than num by 2. All right. So that's our base condition. So I'm going to write if this is going to be our base case. I greater than num by 2, the bracket. Okay. And then the base case would constitute of all the statements that are after the loop, meaning that these statements will be written inside of the base case. So here we're going to write if fact count is greater than 0, then we should return true, else we should return false. Now let's write our recursive case. Now inside of the recursive case, we are going to write the statements that belong to the body of the loop as well as the update condition. So the body of the loop constitutes of this: if num mod I equals 0, if num mod I equals 0, Then we are incrementing the value of fact count on plus plus, and our update expression is I plus plus. Okay, so that's what I'm going to write here, I plus plus. And then to continue on with the process, we must make a recursive function call. So a recursive function call will be preceded by return, because this function has a return type, and then we're going to call this function and pass it parameters in order. So first we pass it num, and then fact count, and then I. And that's it. Our recursive function is complete. So let's test this by writing the main method and giving it a few inputs. Public static void main string args. Next, we need to make an object of the scanner class. Scanner system.in. Then we'll create an object of this class. Alright, so let's first take the number which needs to be checked. System.out.print. Enter a number. And none. Go to sc.next int. And then we need to check if obj.rec composite v1. Alright. Now, other type of calling, because num does not have any initialization values, therefore we are going to pass it num, because we need to find out if num is composite or not. As for the fact count and I, for these two variables, we will pass the initialization values in the iterative function. So in the iterative function, we are initializing fact count with 0, and we are initializing I with 2. I'm going to pass it 0 and 2. Now, if this returns true, then I'm going to print system.out.println num is a composite number. Let's copy this. And else, if the function returns false, then we are going to write num is not a composite number. That's it. Let's compile this. Then let's run this program. Okay. So let's enter a number. Let's say the number is 5. Now we know that 5 is a prime number. It's not a composite number. And 5 is not a composite number. Let's enter 16. That's a composite number. It is a composite number. Let's enter 11. It's not a composite number. So this program does work. So following the steps that was discussed in the previous video, we can find out the recursive version of an iterative program, right? So I hope you've understood this. If you haven't, go over this video a couple of times and I'm sure you will get it, right? So see you in the next one. Bye for now.